The scissor lift mechanism looks something like this. This design requires a nice symmetry concept. You know, if you were to draw a line right down the middle, right, put a bar right across the middle here, then both sides would have to be the same, which means that when, you know, that car is on top of this structure, both sides are getting equal force, and that's where the similarity or the symmetry comes into play. So here's an example of this scissor lift kind of idea, right? So what we're going to prove here is that if you see this little vector in here, this is kind of like the force. Is if we lift something and this is getting taller, the force is getting shot right down the middle. What we want to know is if this has equal force on both sides, then this angle right here and this angle right here have to be the same, right? So as this is going up, if they're the same angle, that means then force is going to be the same or applied the same on both arms, and that'll be the best functioning scissor lift. So that is what we're going to prove. So here's a diagram of the scissor lift idea. So this segment here is representing kind of that force as this is growing or shrinking. That force that makes it grow or shrink goes right down the middle. So what we want to prove here is that if both sides are getting equal pressure, that means that the angle that these two arms are from this force going right down the middle, they have to be the same angle, right? Because if they're the same, then the forces are going to be behaving on those arms the same here. So what we're given in this problem to prove that those angles are going to be congruent, we're given that we have a rhombus here, right? All four sides are congruent to each other. Okay, so then our job is to prove that this angle right here and this angle right here are congruent to each other. Okay, so that's what we want to end our proof with, that angle BAC is congruent to angle DAC because of whatever reason, that we can say that. So here's how we're going to make our argument for our proof. Remember that we start every proof with given information. It's always our starting point. It's what we know to be true and what we work from. So given that we know that those segments are congruent, what else can we state so that, number two, we can then make the logical arguments in our proof that can state that two triangles are congruent. Because if we can get two triangles to be congruent, then we just know mathematically that their corresponding parts therefore have to be congruent. Okay? So before we can state that two triangles are congruent, we have to argue one of those triangle congruency combinations exists of what we know as congruent parts. So are there three congruent segments in both triangles? If there are, we can say that the triangles are congruent by the side, right? Or if there were two sides and an angle in between the two sides that we know are congruent and an angle that we know are congruent, then we can say side angle side and whatnot. So to be able to use those combinations, we have to make those congruency statements in our proof, and then therefore we can say that two triangles are congruent. And then once we have the two triangles are congruent, then we can go ahead and say by CPCTC, because corresponding parts of congruent triangles are congruent, right? That's what that stands for. Just understand the logic behind the letters. But once we have two triangles congruent, then we go ahead and say that those corresponding parts are congruent. And by corresponding parts, this angle corresponds to this angle, right? If we were to fold the bottom one up on the top triangle, these angles would correspond, right? So they have to be congruent if we know that these two triangles are congruent. And so that's how the proof is going to go. So see what you can do on that. Good luck, guys.